Hello, 8th graders. We are starting in 8M7. This is the last unit that we're going to learn in technically the 8th grade Common Core curriculum. Before we move on to algebra, it's going to be we're going to start off with learning the Pythagorean Theorem. I think that you may have heard of this, know what it is, know how to use it, but we need to be masters of wielding this famous equation that has been around for longer than 2,000 years. So let us commence by understanding what it is, how it's used, and get you acquainted with it so you will be able to come to class on Monday ready to demonstrate your knowledge of the Pythagorean theorem. So let us move over. What I'd like you to do now is, as we go through this lesson, what I'd like you to have up, 8M7 lesson 1 in your binder. So have that in front of you because we're going to be working problems straight from that lesson. So take a look over here. This is page, the beginning of section unit 8M7, and we're going to use these examples to work through, and you will help me solve these problems, and then we will come to class ready to do more problems on Monday. Have notes. You take notes. Take notes. You can't, in binder is okay. But I want to see with my eyeball. I want to see notes on Monday. Okay, good. We got it? All right. So the first thing we want to know is the Pythagorean theorem. We want to understand what it is. And what it says basically is that the sum of the squares, you don't need to write this down. This will be at the end. The sum of the squares of the legs, we will define that in a second, of a right triangle. Yeah, let's spell it out. Triangle. We'll define right triangle too. I think you know what that is equal to the square of the hypotenuse. The hypotenuse. So we need to define these three things. So let's look over here at this triangle here, and let's see if we can make sense of what a right triangle, of the legs of a right triangle and the hypotenuse are. So the idea is a right triangle is one that has a right angle. A right triangle has one right angle. Now, a triangle can't have a right angle, and now let's look at, so that's a right triangle, and a right angle is simply an angle, right angle is simply an angle with that measures 90 degrees. Now, a 90-degree angle is something you should know from 6th grade and 7th grade, but it's one that is like squared off. So, for example, a right angle would be this. This would be a right angle if it measured exactly 90 degrees, and so we denote that like this. Another way that we denote a right angle is we simply take an angle and then we put a box on it. So this denotes, in other words, it means a right angle. And we can say angle like this. Sometimes this is shorthand for angle. Shorthand for angle. So let's look over here at the left. And so this is a right, we'll spell it out, a right triangle, because it has a right angle. Okay. So the legs of a right triangle. So let's talk about the legs. The legs are the two sides of a right triangle that make up the right angle. So that's the legs are the legs are the two sides that make up the right angle. So in this triangle over here on the left, this would be a leg and this would be a leg. Now the hypotenuse is the side, and I'm just going to erase a little bit here. I'm just going to erase this, and I'm going to say that the hypotenuse is the side that is not one of the two legs. The hypotenuse is the side that is not one of the two legs. Or it's otherwise, or it is the side opposite the right angle. The side opposite the right angle. So if this is the right angle, then that is the side opposite. This is the opposite. Okay, so now that we've got all these definitions out of the way, we can go into the Pythagorean theorem. Again, this is the Pythagorean theorem here. The Pythagorean theorem, there it is, the definition right there. The sum of squares of the legs of a right triangle is equal to the square of the hypotenuse. So what we can do is we can say that on this triangle here, that the hypotenuse, which we denote this way. We say the sum of the squares of the legs. So if we denote on a right triangle, we always call one leg A and another leg B. We always call the hypotenuse C. And that's just the nomenclature that we use when we're dealing with right triangles. And remember, that's the hypotenuse because it's opposite the right angle. And so these are the two legs because they comprise the right angle. So what this says over here, the Pythagorean theorem says that the sum of the squares, so the square of one leg and the square of another leg. So that is the sum of squares of legs. equals the square of the hypotenuse. Well, if the hypotenuse is c, then the square of the hypotenuse is c squared. So in this example, all this is saying is that c squared, the hypotenuse, is equal to, well, we know what a is and b is, so we'll say that 4 squared plus 9 squared, that's a plus, equals c squared. Or that 16 plus 81 equals c squared, or that 97 equals c squared. So we're just going to stop there. We're not going to solve for c just yet, because you'll notice that c is not an even integer. It is not an integer answer, because if c squared were 100, then we'd know that c was 10. If c squared was equal to 81, then c would be 9. But as we learned early in the year, that c then must be between 9 and 10, because c squared is less than 100, which is less than 81, right? C squared is 97, so 97 is between 100 and 81, so that c must be between 9 and 10. Okay, so let's just leave it at that. We're just going to estimate, say, well, c is between 9 and 10. We've written our equation. So let's erase that for now, and let's come back and leave a little space and solve this next one. So let's just write an equation here that determines this side. Let's use this color. So let's identify, first we need to identify our legs, A and B. It doesn't matter which one you call A or B for the legs, but you definitely have to get C correct for the hypotenuse. So we identify the hypotenuse by finding the right angle and going opposite. So this must be C. So either one of these sides can be A and one side be B. And so we know that A is equal to 8 and B is equal to 3. And these are in centimeters, but it doesn't really matter. We just know that our answer has to be in centimeters. So our equation is, again, A squared plus B squared equals C squared. And so 8 squared plus 3 squared equals C squared. So 64 plus 9 equals C squared. So 73 equals C squared. So if we want to estimate C squared, we know that it's between 8. C must be between, well, 73. Let's figure this out. 73 is between what two perfect squares? Well, it's between 64 and 81. So we know if that's C squared, we know that C has to be between 8 and 9. Right? C squared is between 81 and 64. So that C must be between 8 and 9. And we learned that earlier in the year. So if this is confusing to you, come ask me about it, or go back in your notes and remind yourself why, if C squared is between 81 and 64, that C must be between 8 and 9. And I'll draw you some little arrows that will help you kind of figure this out. Right? 8 times 8 is 64, and 9 times 9 is 81. So C times C, if it's 73, must be between 8 and 9. So, but let's keep continuing forward in our in our unit here. And let's look at a few more examples. So maybe it's hard to read this. I know that sometimes the videos come out a little bit fuzzy, but if you're following along in your notebook, in your binder, you should be able to read this. And basically what it's saying is that you have an equilateral triangle. So this is kind of a trick or kind of a word problem, right? You have an equilateral triangle and a height is 10. So let's write an equation that might help us figure out the sides of this equilateral triangle. Well, I know that an equilateral triangle, all sides are the same. So let's just call this, x, or let's just call this C. We'll call this C, and we'll call this C over 2, and this C over 2. Well, why? Well, it's an equilateral triangle, so I know that all sides have to be the same. And I know that this is my right angle here. So if all sides are the same, then this half has to be C over 2, and this half has to be C over 2. So now I can write an equation that says 10 squared. Or let's identify. Let's just look at one of these right triangles. Let's look, say, at this one. Let's just look at this right triangle. This is a right triangle because we see that we have this right angle here. And so we know that this is our hypotenuse. This is our hypotenuse. Now, we know that then this becomes A and this becomes B. So I know that this side squared plus this side squared is equal to this side squared. So let's go 10 squared plus C over 2 squared equals C squared. And that's our equation. Now, we're not going to worry about solving this one yet, but that's what we can say about it. And we have a way of solving this, but we're not going to worry about that right now. We're just worrying about finding patterns, looking at pictures, and making deductions about what must be true about these right triangles. Now, I'm going to let you try this exercise 1 and 2 on your own. So please give this a go. I want you to, 1, label the hypotenuse. C. Find the hypotenuse, decide that's the hypotenuse, and call that C. And then write your equation. Okay, now, and do the same thing. Do the same thing down here, also on number 2. Okay. So I'll let you do that and then come back. So pause the video. So now pause. Pause and solve these two things. Okay. Now we're back. Now we're back, and I want to just make sure that you got this right. So this is correctly, because this is the side opposite, this is C. So we can call either one of these A and B. We'll call this A and this B. So we know that A squared plus B squared equals C squared. So we know A and we know C. So we know that 6 squared plus B squared equals 11 squared. So we know that 36 plus B squared equals 121. Now, 121 minus 36 is equal to 85. So we know that B squared equals 85. So we know that B is between what two numbers? Well, we know that 81 would be 9. So we know that it's between 9 and 10. Because remember, B squared is between 81 and 100, because B squared is 85. is between 100 and 81. So we know that B must be between 9 and 10. Likewise, on number 2, which I hopefully you solved, is you said, well, this is my C, this is my A, and this is my B. So A squared plus B squared equals C squared. 6 squared plus 10 squared equals C squared. So 136 equals C squared. And I know that 136 is between 121 and 144. And this is, so C is between 12, which is the square root of 144, and 11. Right? The square root of that has to be less than the square root of that, which has to be less than the square root of that. So C is between 11 and 12. Okay, hopefully we're getting the hang of this. Let's move forward. And let's look at number 3. So let's do one last problem, and we'll figure out, I'll let you now pause and solve. Okay, now I trust you're back after solving this equation and knowing that you first identify your hypotenuse. So that's our C, this is our A, and this is our B. So we don't know B. This is the thing we're solving for now. We know A and C. So we can write 9 squared. I'm going a little shorthand on you. B squared equals 11 squared. So 81 plus B squared equals 121. So keep going. B squared equals 40, which is 121 minus 81. And so B squared is between what two numbers? What two square numbers? Well, that's between 36 and 49. So that B is between 6 and 7. Good. So hopefully in this unit you've learned, let's keep going, and you can go to the summary page, and it explains to you a little bit about the Pythagorean theorem. It just kind of says, well, it actually doesn't tell you what the Pythagorean theorem is, which, but it does give you an example. It kind of uses the example of A squared plus B squared equals C squared to give you an estimate for the hypotenuse, right? So we know in this case that A squared plus B squared is C squared equals C squared. They fill in the numbers for you. You know that that's C. So we get 9 plus 49 is C squared. C squared equals 58. So you know that the answer is between 7 and 8. And there's our summary. What I want to see, what I need to see evidence that you followed this lesson by working the problems in lesson 1. This is what I need to see. Okay, that's all we have for today, and we will get back to, we will start picking up with and moving faster through the Pythagorean theorem when we return to class next. Thank you.